Hello, everybody. This week we are going to be going over Chapter 2. Kind of just depends on how fast the video goes, if we'll finish the chapter or not. If you think that the class is going kind of slow or maybe the videos seem too short, what I'm trying to do is make sure that I'm not going any faster than what I do in class. So the videos seem, to me, they seem short compared to when I would host lectures, but I've kind of chopped that up to there's people aren't having questions, I'm not walking around, there's no in-class time for you guys to work. So if you think that if lectures are going short and it doesn't seem long enough, just remember that some of that stuff isn't happening. So I think that is saving some time. My biggest fear is going too fast. So I do not want to end up going too fast and then someone kind of getting left behind. So give me some feedback. Once again, you can go to the general feedback. You can go to the video feedback. But this week, like I said, we're going to be going over Chapter 2. We're going to get at least halfway through it, if not the full thing. And then no matter how far we get through it, I'm going to be releasing homework number 1. The reason behind that is because I always give 2 weeks for the homework because I want you to have 2 weekends. One weekend to look at the work, kind of get an understanding. You might not know how to do all of it, but you're definitely going to know how to do some of it. Once I release week 3 video, you will then 100% know how to do every bit of it. And remember, when I mean that you know how to do every bit of it, it means that I've taught you the tool to accomplish whatever the tasks are. It does not mean that I'm going to teach you exactly how to do that one problem that I'm asking you to do, or the 2 problems that I'm asking you to do on the homework. So let's just make sure we're clear there. And like I said, it kind of just depends on how far we get in this chapter. I'll have a better understanding at the end of this lecture how far you'll be able to go. I think what I'll do is when we're done with lecture, I will pull up the document that I release that tells you how to do the homework or what I want for the homework, and we'll just kind of walk through it step by step, just make sure that everyone understands what I'm asking and what the problems are. But please, if you guys have questions about the homework, I put up another discussion board. You need to go out there and you need to start asking some questions. If you know the answer to a student's question, please feel free to answer it. Okay, we can all kind of work together here. But I will do my best to get on here and answer questions during my office hours and outside of my office hours if need be. So what I want to do is, like I said, this week's a little bit different compared to last week because I'm going to actually pull up the PowerPoint and we're going to kind of walk through it. One of the things that I'm not going to do, and I think once again this takes away a little bit from the class time, is I'm not going to walk through this slide by slide and read it to you. In my opinion, with this being an online course, that's something that you're all capable to do. You're all capable to get online, review this. You don't need this to be a 2-hour lecture video where I'm just walking you through. So really what I want to do is kind of go through the PowerPoint, which I'll pull up now. I want to go through this Chapter 2 PowerPoint, and what I want to do is pull out some of the key things and load up Visual Studios, and then let's start to code this, okay? So one of the main things here is just kind of looking at the structure of your code. One thing that you need to understand is the computer doesn't care how you write it. Okay, so if you're looking here and you can see my mouse, I hope that you can see my mouse kind of moving there. There's indentation. There's brackets lined up here. There's semicolons at the end of statements. Some of the stuff the computer doesn't care about. So there's a debate between new line or same line brackets. Okay, everything that I write will have new line brackets, meaning that once I write a function, and you might not know what a function is, but we'll get to that, I put the bracket on a new line. Some people like to put this bracket up here. Your compiler does not care. Same with this indentation. The compiler doesn't care if there's an indentation here. It will still read this and understand what to do. However, you need to write your code in a way that is easy to read. For me, that means I'm indenting quite a bit. When I write a function, I tab and I indent. If statements, I'm going to tab and indent. While loops, I'll tab and indent. And we'll get through some of this stuff. We'll understand a little better as we move forward here. But I need you to kind of get the understanding of making this code look nice. Okay? I had an instructor once who said it's like a piece of art. I don't know if I would go that far, but you do have to have some kind of formatting here. Okay? So two of the things, this here is a very, very simple example, but one thing that you'll see me do even as we progress and we're week 10 into this semester, I'm still going to write a very simple program just like this every single time I load up Visual Studios and run it. That will ensure that I have everything set up and ready to go for the new algorithm. So include statements. An include statement, what that means is it's basically giving you access to another part of the program. It's allowing you to use specific tools that already exist. I relate this to having to not recreate the wheel. So one thing that we're going to include every time is IO stream. It stands for input output stream. So keyboard input, output to the command line. Okay? We have to use that every time because in almost every program we make, we're going to be writing cout statements, which is what this is right here. So this, include IO stream, what it allows you to do is have access to some of the stuff inside of that program. One of them being cout, which stands for console out, write to the console. The next thing, even more specific, is a using statement. And what that says is, inside of IO stream, there is a namespace called std. Inside of there exists this terminology called cout. There's a bunch of different ways to do this, but for me, what I like to do is have this using namespace std. Okay, some code that you'll see cout here, and you'll see std : cout. Either way works, but I'm always going to include namespace std. Int main, we're going to get back to this. I will briefly talk about it, but we'll get back to this when we start to talk about functions. So what int main is that's our main function. What you need to take away from that is every bit of code that you write until I tell you otherwise will go between this bracket and this bracket. No exceptions. If you get online and you start to see people writing stuff outside of main, that's fine. They can do whatever they want. You are not allowed to copy that code and use that. Okay, you cannot have code written outside of main. This is once again a spot where you need to be taking notes. Okay, when I dock you points on your program because you used a global variable, and then you say, well, I didn't know I couldn't do that, we're going to have some issues. Rewatch the video, take some notes. Okay, there are bigger issues even besides saying I didn't know that. Well, at that point, you're cheating because you don't even know what a global variable is then. Okay, so some of the stuff you see online, I'm going to be able to immediately pick out and say there's no way that you knew how to write that. There's no way that you know what this bit of code does. So be very careful when you are online sorting through stuff, trying to figure out what is a resource and what is cheating. Remember this / forward slash, that means it's a comment, and that means it's read over by the compiler. I'll let you look at some of these. The big one here is going to be the semicolon. You have to put a semicolon after every statement that we write. That is going to be the biggest error that you guys have, is that you'll forget that semicolon. So the first thing we want to talk about is the cout object displays output to the computer screen. So at this point, what I want to do is I want to load up Visual Studios, and I have a few instances because I'm going to be using some examples that I've made. And from here, I want to create a new project. I want C++, and I want a console application, and I'll say next. And I want this to be saved. I changed the folder that I had, so I gotta come back in here and find it. Want it stored on my flash drive in coding examples. I want its name to be CIS 150 underscore 08 dash 30 dash 2020 underscore C out, and I'm also going to put variables, because in this chapter we'll get to variables as well. So I'm going to say C out, variables, and then I'm going to say create. The first thing we want to do is go ahead and get rid of all this junk that it's already made, and delete this, and we need to make our own header. Put my header, I'll put the author, the date, and we'll say that it is 08/31/2020. And the description, remember the date's going to be off. I'm recording this a week in advance. The only reason I'm saying that is because it's starting to confuse me. When I'm looking at this and saying, wait, is this supposed to be chapter 2 work or chapter 3 work? What am I doing here? So that's the only reason I'm saying that. Maybe you're doing better with that than me. So I'm going to say simple program looking at cout and variables. We'll say and variable definition. And then this is what I do if the description's longer. I don't like letting it go past. It's just me. You could say it's just being picky. I don't care what you do, but this is just how I like to do it. Variable assignments. And I think we might get a little bit to CN, and I'll put in there user input, because that's what CN is, console in. And I'll go ahead and end this. And the first thing that I like to do is just go ahead and let's just give this a run. Let's just guarantee that this looks good, that we can actually see this hello world displayed to the console, and we can. So everything's good to go. Remember, yours is going to look a little bit different here. It all just depends on where you save it. Okay. So notice what they did. They're not using that using statement. Okay, what they're saying is inside of std, using or included in IOStream is something called cout. I personally don't like to do that. I like to do this, using namespace std. At this point, we can eliminate this. Okay, but what I want to show you is along the way, I like to just show some errors. Okay, so I actually don't want this to be read, so I'm going to make that a comment. Okay, it says the compiler will go ahead and read over that. We don't have a using namespace std anymore. Let me go ahead and zoom in. I just looked over at the monitor, and that might be a little small. Give me some feedback if you can't read it. But if we hover over, it says identifier cout is undefined. What I want you to maybe write in your note is if you get this error, maybe you're not including or you're not using namespace std. Okay, at this point, it is gone. You will come to realize that these things here, these errors that we get when you hover over them, they're not the best. Okay, you could get identifier cout is undefined for many things. You could get all sorts of errors, and you have to like make your own repository of error messages. When I get this error message, this seems to happen. Okay, it could be one of 5 things. Maybe I forgot a semicolon. Okay, all that is practice. You have to practice with this stuff. Okay, so even when you're not coding for my class, it should be somewhat of a passion for you. You should, and I'm talking to computer science app development majors. If you're cyber, I understand you might not really like the software engineering aspect, and I get that. But for my computer science majors, you want to mess around with this stuff and start to, like I said, make your own repository of things. So one thing that I would ask you right now, if I were in class, and I know I can't get any feedback, is that this looks a little odd to me. Okay, and these are things we have to pick up as software engineers, coders. We have to pick up on this. If you notice something, and I'm going to go ahead and run this. Something seems off. And what I'm seeing is, why is this /n? Why is that spot right here? Why is that not included when we output to our console? The reason that is like that is because a \n stands for a new line sequence. What it means is that we read up until this character, but that character or that sequence of characters is interpreted differently. The computer interprets that and says, oh, that actually means that I want a new line there. Let's look at the difference here and run this. Notice how there isn't that gap between what we actually wanted and then the jargon after. Well, that's because you didn't tell it to have a new line there. If we add that \n back in there, it prints a new line. Give me one new blank line. We have that blank line. So that's just something to make sure that you're aware of. That's why that looks a little different. So let's say that we wanted to write something, and we'll say cout. Hello, this is a test. Okay. At this point, what if I said I wanted you to write something on the next line that said, this is another test? How could you do that? I want one line to say, hello, this is a test. Another line after that to say, another test. Pause the video, see if you can get it to look like the command prompt that I'm going to show next. I'm going to pause the video, code it, and then show you. So how could you get your output to match mine and look like this, where we have two separate lines? Pause the video, and usually in class, I would ask you to try to do this for 10 minutes on your own. 5 to 10 minutes on your own. I would recommend you do the same thing. So pause the video, see if you can get it. If not, I'll show you the solution. Okay, hopefully you were able to figure that out, but this relates directly to that whole thing of this class's problem solving. I never told you some of the stuff. I never told you how to do this, okay? But what I did tell you was how to print to the console, and I also told you how to make a new line, okay? So what you should have done is something that looks like this. You should have decided, you should have tested, you should have understood that you maybe needed 2 lines. Maybe you didn't. Maybe you needed 2 cout statements, but you 100% needed some kind of new line character saying print this next stuff on a different line. Okay? What you might have tried is something like this. Cout. Hello, this is a test. And then you might have went along and said cout. This is another test. If you do this, these 2 things will print on the same line. These 2 lines will be displayed on the same line in our output. I put these comments in so when you're looking at the code and you're coming back, you understand what it does. My in-class or my online lecture examples will always follow this trend here. Okay? I'll put this here. These 2 lines will be displayed on 2 different lines in our output. Okay? So let's just go ahead and comment this out. Control KC, hit them all at the same time, and you can do a mass comment. All I'm saying is I don't want to see this output anymore. You can go ahead, the compiler can go ahead and read over this. Run this, and we should see everything just in one straight line across in our console, which is what we get. No space because you didn't tell it to have a space there. You never put a space at the end of this. Okay? So I'm going to X out of this, and I'm also going to comment this out. I want to, oops, the difference between, I don't like these, okay? The / ***/, that is a mass comment that says anything from this spot to this spot, comment that out. I'm not really a big fan of that. I don't know why. It's just standards. You'll come up with your own. I like to just do the //. I'm going to write another comment. This is another way to write, let's say, display output on let's say a new line to our output. So what we can say is cout. Hello, this is a test. And what we're going to write is something called end L. That means end line. That means in this line, and the next thing that you use for cout, I want it on a new line. This is another test. This will now display this on one line and this on another. Okay, so let's go ahead and run this. I personally will always use the end L. First line, second line. I will not use the \n. I don't know. That's just my own standard. You need to make your own. I do not care what you do, though. Okay? Be consistent. That's all I would say. That typically helps students more than anything, is just being consistent. So I'm going to go ahead and comment that out as well. Because I'm going to upload this work. If you need to come back and look at this, you should take this and understand that from here to here is a specific example. Uncomment this. Okay? From here down is this example. I'll put another header for our next example. I hope that this makes sense. If you don't get what I'm doing here, please let me know. But one thing that I don't want to do is have to make 1, 2, 3 new projects, upload all those projects. This is for on a new line, this is on the same line, and I find that more confusing. Okay, so I'm going to keep everything inside of one project and then go ahead and upload that one single project to Brightspace. All right, so we're kind of understanding how cout works. We're understanding how things are formatted together. One thing that I want to look at is just saying this is how you can display multiple, we'll just say multiple things in one output statement. So what do I mean by that? Well, what if I wanted all this, but I didn't want to have to write cout twice? Cout, hello, this is a test. Put an end L. And then I also want to go ahead and say, oops, this is another test. Semicolon. This, although we are seeing it all on one line, this will end up being printed on 2 lines because we put the end L in there. So let's go ahead and run this. What I need you to understand is that just because it looks one way in our IDE on Visual Studios does not mean that's how it's displayed here. Okay? So this ends up being 2 lines because we have the end L. I'm going to go ahead and comment this out and get ready for our next in class, or whatever you want to call it. Pause the video. Let's try something. So what I want you to do is I want you to try to make your output console look like this? How can you display this set of stars to look like that triangle, this set of stars to look like that triangle, and this set of stars to look like this triangle? Once again, this is the problem-solving aspect. I know I didn't teach you this, but this could have easily been a quiz next week, okay? Where it's the whole aspect of problem-solving. How can I use what I was just taught in order to get this particular output? That is how my quizzes are ran. Look at this output. Now you do the code to make your output match mine. Okay? So right now, I want you to pause the video, and this one I would probably give about 10 to 15 minutes. Take 10 to 15 minutes to see how you could, how can you write the code in order to make your output like what I just showed. All right, so hopefully you were able to get your output to look something like what is shown here. If you weren't, it is not a big deal, okay? It's once again the aspect of problem solving. It takes practice. It takes a little bit of time. I will be honest, the first time that I started coding was in a class just like this. We were given the same assignment, and I was unable to do this in the time given. Okay, so it's just a matter of problem solving. How can I do this given the specific information that was given to me before? Okay, so let's go ahead and look at the solution here. The first thing I want to do is do this, the triangle that is like a right triangle here. And I guess a right triangle with the base on the bottom. So I output one single star with an indel. Then I output 2 stars with an indel, 3 stars with an indel. And then all I'm doing here is just for formatting, just to get a couple spaces between this star and the next star. Okay, so this is how you can, and I'll just put that there. This is how you can create a couple lines between the triangles. Next star is the right triangle. I'll just call it the right triangle upside down, okay? Where it has the base up top. So I need 3 stars. And then I bet a lot of you just did something like this. Then I need 2 stars. If you notice, it didn't match mine exactly. Just put a space in there. Well, at that point, then that should have told you that you need 2 spaces on this one. All of these have indels after them. Okay. So the next one is the equilateral triangle. Once again, I didn't know exactly how many spaces to have here. It was trial and error. Maybe it looked something like this and it looked off, right? It is all just a matter of keying this in and trying to understand how many spaces need to be at a given spot. Could you have done it like this? Could you have done that, and will this run the exact same? If your answer is yes, you're correct. But my issue with this is, can I look at this code here and understand if it will print the triangle the way that I want it? The answer to that is no. I would have no idea how this will actually get printed to the console window. Whereas if I'm writing it like this, I can see how this looks and how it will be displayed inside of the console. Okay, so that's something to just kind of get used to. Is this something that you want to be able to see visually right here on through your code to know how it will look? Personally, that's how I do it. Okay, I feel like it takes a step out of getting your code 100% right. You're kind of taking a little bit of this away from guessing. This doesn't feel like a guess to me. It doesn't feel like when I run this, it's either going to be right or not. I should know by looking at this that this is going to make this triangle the triangle that I wanted. okay? So make sure that you understand, if you did it all in one line, there's nothing wrong with that. I guess I want to be clear here too. That is another spot where I typically find cheating, is if someone came up with a very unique solution, I'm like, wow, that's very unique. I wonder how they came up with that. And then I see that solution again. Well, then a red flag goes off, like, those two must have had the same thought process. And then I see it a third time. And then I realize, and I know this is different for this class, that those 3 students all sit together in the back row. Okay, they must have just shared their solution. So now I go in and I look at variable names, and they're all the same. Line numbers are all the same, meaning line 44 is the same here as it is on this person's code as it is on this person's code. Same with 46 and 48. These are huge red flags. You know what another huge red flag is? When you forget to change your name. Please don't do that. Right? I'm okay with you guys helping each other, but the line that I typically draw is when you start emailing code back and forth. Typically, that does not end well. Meaning someone's going to end up copying your work. Whether you wanted them to or not, I wouldn't know. So I have to give zeros all the way around. But it's something that you have to be careful of. And once again, like I said, my line in the sand is if you're emailing code back and forth or if you're writing code for somebody else. It's typically pretty easy to see that. Okay, so just be careful. If someone emails and says, hey, it's late, I didn't have much time, could you just email me yours so I could just look at it? I just want to take a peek at what you did. Once again, that usually doesn't go well. Okay, so just be careful. What I'm going to do is go ahead and comment this out. And I think what I'm going to do to try to actually make this a little bit easier to see is I'm just going to put a little bit of separation here, just so that way you know where the headers are. This is a new example. This is a new example, okay? And if this doesn't make sense, like I said, just put on the discussion board that I don't know what you're doing. I'm not sure what you're saying. All I'm trying to do is just make sure that I don't have to create the same, or I guess I should say multiple projects over and over and over again. Whoops. I wonder if anyone's here listening right now. If you're here listening right now, go on the discussion for this week's video. Post whether you were able to get the triangles or not, and I'll give you 2 points extra credit. I gotta see, gotta make sure. Okay, so if you're listening, go do what I just said. Okay, let's go ahead. Maybe I'll give you 5. We'll see. Let's go ahead and start with looking back at the PowerPoint slides. So I'm going to minimize this. We've already walked through some cout statements. Indel, we've talked about that. We've looked at the differences here. Notice that this is an L. It's not a 1. I've never really had students have an issue with that, but it does say it in the PowerPoint slides. And again, just because I'm kind of flying through these slides doesn't mean that they're not important. These slides are important. You need to go through them at your own pace, read them all, make sure you understand them. I'm picking out the key spots here. Okay, the include directive we've already talked about. Next thing I want to get to is variables. Okay, and this will probably be the last little bit that we cover here. Variables is kind of in depth. So, a variable is a storage location inside of memory. Okay, this is a spot inside of memory where something is stored. It has a name and a type of data that it can hold. And it must be defined before it can be used. Okay? So at this, what we're looking at is an int, an integer, one whole number. That's what an integer means. A whole number. This variable is then called item. Okay, so we have an int variable, so some variable that can hold a number, and then we have a name for that. And the reason that we do this is because if we didn't have this specific name for this variable, what we'd have to do is reference its hexadecimal memory address location. which is a long slew of digits and numbers, to represent where is this thing actually being stored inside of memory. I personally, if it were me, would not want to do that. Okay? I would not want to know or have to remember that this is at memory address whatever. This is at this memory address. We're going to reach programs where we're going to have 50 variables. Possibly more. I don't want to have to remember all of those different memory addresses. I would rather have some kind of name for this, some kind of descriptive name for this. Okay? So we're just going to look at this example. Actually, let's just go ahead and load up Visual Studios and talk about some of the stuff that it says. Okay? So, one of the things that it says is that it must be defined before it is used. So let's look at what a definition is. I'm going to say, put this header in, and I'm going to say, looking at variables, and we'll go ahead and pop this back in. I'm going to say int num, and we're going to say this is a definition. This defines a spot in RAM for an integer to be stored. All this does is it goes to memory and saves a chunk of memory. I don't know if you need it yet, but I'm saving X amount of bytes for this particular integer, this particular variable. I'm going to say this is a variable definition. Well, what if we wanted to give that number a value? I'm going to say this is a variable assignment. This gives a value to the defined RAM address. It gives a value to the defined RAM address. I'm just going to put in parentheses, or the variable called num. I'm not going to put or there. That means it's this or that, and that's not true. It's actually for both, right? This is one way to put it as in regards to the RAM, and this is another way to state that same thing in regards to your actual variable. Okay? So at this point, I say num is equal to 5. You were just given a value. The value of 5 is now stored inside of the variable called num. So let's do this. Cout num is equal to, well, how can we actually see this? We're going to concatenate what's called a string literal, which is in between the two quotes, a string literal, with the variable that we just called num, with an indel. Output a string literal and the value stored in the variable num. Okay, so let's go ahead and give that a run. We see num is equal to 5. It's exactly what we want. 5 was stored inside of this variable, and now we are trying to decide what it is. Or now we're trying to see what that value is. Okay? Do you think that we're going to have values or variables that have one value and they just stay the same for the entire program? Meaning, does num stay 5 for the entire run of the program? Typically, no. So what we need is something like a reassignment to the variable num. I always do that, where I put a semicolon at the end of my sentences. So what I'm going to say is, well, num is now equal to 99. Cout num is equal to num with an indel. Now we should say num is equal to 5, num is equal to 99. And let's give that a run. Num is equal to 5, and num is equal to 99. One thing to be clear is that this num does not get changed until line 73. Okay? So it's something where we got to understand that in coding we work top down. It's just like reading a paper. You read from the top down. You can't read a book and in chapter 2 they're referencing chapter 10. It doesn't make any sense. You would have no concept of what's going on in chapter 10. You haven't gotten that far yet. Well, at this point in time, I only know that num is equal to 5. Okay? So I'm going to go ahead and comment this out, and I'm going to say Control KC. And just so we're clear, in order to uncomment something like this, you don't have to go line by line and delete it. What you can do is Control KU. Control KU. It's a mass uncomment. Notice that my comments, the actual comments, don't get uncommented out. The reason is because when you say Control KC, whoops, this actually ends up getting 4 comments, 4 lines in front of it. So it's only going to delete the 2 of those 4, okay? So something that I want to look at is, I think I can do that again, yep, okay, is using variable before the definition, okay? So I guess what I want to kind of look at here is, what if I said cout and I said that I want to define a number called x, I say, or we'll call it new num. New num is equal to, and we'll say new num with an indel. I say int new num is equal to 23. You're going to notice that you get a syntax error. Okay? Anything that has red underline, that is a syntax error. So the syntax error, if we hover over it, it says identifier new num is undefined. The reason for this is because I only know, on line 81, I only know the 80 lines before me. New num has never been defined. I don't know what that is because it is defined on line 83. This will not run. So I'm going to put this. This will not run. This is a syntax error. You must define variables before you use them. Okay? I'm going to go ahead and comment all this out as well. The next thing that I want to look at is combining these two things. So combining this definition with an assignment. A lot of times we will have a definition and an assignment together. Variable, definition, and assignment on same line. Whoops. So I'll say int number is equal to 25. Cout number is equal to the actual variable number. So we've combined the two steps here. Okay. Can you do it all the time? No. It really just depends. Sometimes we need the user to give us the value. Sometimes we know what the value will actually be. Sometimes the value never changes and we never have a reassignment. It's all just kind of dependent on the program, okay? So I'm going to do a Control KC, and I'm going to minimize this here, and we're just going to kind of look through some of this. This is just showing you some of its own code, looking at definitions. I'm going to go ahead and go through string literal and integer literal. And this is just kind of what we already did, so we'll go ahead. But just make sure you understand that this is looking at some code, and then this is going to be the actual output itself. Okay? Couple string literals. Identifiers, I'm going to let you go ahead and look at the identifiers. All it's saying is that there are some words that you can't use. There are some words that you couldn't make a variable called break or case because those are reserved words. And we'll get to what a lot of those mean, but you can't just use those words. Okay? Something that you noticed on my program already is that I did something like this, int new num. This is what's called camel case, and if you notice, I don't put spaces in any of my file names either. Reasoning is because when you start to work with spaces, it makes it harder for different aspects of computer science, I guess is the easiest way to put that. So I use what's called camel case. Start with a lowercase. Anytime you have a new word, change the first letter of that new word becomes a capital letter. Okay? You will see me do that a lot. So if I needed something like items ordered or something like that, it would look something like this to me. Int items ordered. Int number of items. So number of items would look something like that. It's camel case. That's what we call that. It makes it a lot easier to read than just all lowercase. Another thing you might see is something like this. Int items ordered. Really just depends on how you want to do it, but instead of using a space, you're using a underscore. Okay? So it's just telling you this is just some of the standards here. This is camel case. This is looking at it with an underscore. You can't have a period. You can't have it start with a digit, and you can't use special characters. Okay, so there are some rules. Make sure you're reading what the rules are. And then the next thing I want to cover, and this will probably be the last thing that we go over today, is integer data types. So just what is the integer data type? How does it work? Why does it work the way that it does? Okay. So an integer variable can hold whole numbers such as 12, 7, and negative 99. You cannot hold a number like 2.25 inside of an int. Why? Because integers are only whole numbers. Well, of the integer data type, we have 1, 2, 3, 4, 5, 6, 7, 8 different types of integers that we can use. Short int, unsigned short int, unsigned int, etc., etc., etc. Look at the differences. Okay? I'll tell you right now the ones that we'll use most in this class are going to be int and long int. We probably won't really use long int. 95% of the time we're using int. The differences are how much memory it takes up, 4 bytes versus 2 bytes, and then what number can you store inside of it? What is the largest number and what is the smallest number? But we look at this. Let's look at int and unsigned int, and let's look at the difference. What we're saying is that in an int, we can store both negative and positive. In an unsigned int, we can only store positive numbers. However, if we can only store positive numbers, then we basically get to go ahead and just kind of double the size range here. Double the largest number that we can have. We'll talk more, if you're a computer science major, we will talk a lot about this in CIS 268, where we talk about, well, why is it these numbers? Well, it all comes down to bytes. What is the biggest number that you can store across 4 bytes? Something that we have to make sure we understand and we got to kind of get away from is that this stuff just happens behind the scenes and we don't care how it works. That is not going to be good enough as we move forward. We have to understand how it's working under the hood. Okay? So if you take 4 bytes, if you know that, I would ask this, and I'm kind of trying to have to hold myself back from asking who knows how many, because we're not in a class anymore. But I would ask, how many bits are in a byte? We got 8 bits in a byte. Okay, 8 bits in 1 byte. A bit is a single binary digit, 1 or 0. Remember, binary, you should already know this because you've reviewed chapter 1, is 1 or 0. It's on or it's off. It's true or it is false. It is the only thing that a computer essentially knows is 1 or 0. Is this on? Is this off? Given that many bits of on and off, what is the largest number you can hold? The largest number would be all ones. Smallest number would be all zeros. Okay, so given that, that's how we can find this range over here. Okay, like I said, typically we're going to be sticking with the int, and then maybe we'll get into unsigned int, long int. It really just depends on what you need for the program. I always get asked this question every semester. Well, Mr. Moore, if this can only hold this many, this is the largest number I can have, then shouldn't I just be safe and just make this a long int? That way I will make sure that we're all good to go and I won't have to worry about anything. No, you should not. The reason behind that is because you've just added 4 more bytes to your program. Remember, it's going out to RAM. It's running this inside of RAM. Now instead of taking up 4 bytes, you're taking up 8 bytes. What if the number is 5? And you're using a long int? It just logically does not make sense. There could be potential that when you are working in an industry that the programs that you're working on or the computers that you're running on, you do not have enough memory. Your systems crash because you do not have enough memory. You don't want to be the guy who comes in and is, or guy or girl, sorry, who comes in and is using long int for a number that's something like 5. The rule of thumb would be try to find the data type that is closest to the number that you will use. Okay? So, let's go ahead and just look at something here. We've already looked at variables, assignments, reassignments. What I want to look at is looking at the largest and smallest values for an integer. Let's just say looking at the largest values for an integer. And I want to make a number, and I'll say int max num is equal to 214,748,3647. You're saying, where in the heck did you get that number? Well, I got that number because that's the largest number that I can store inside of an integer. Okay? So what I want to do is I want to say cout the largest number you can store in an int is, well, actually let's not say that. Let's just say the value in. The value in max num is, and then we will display max num with an end out. But what if we did this? Int too much, too big is equal to 214,748,3648. If this is the largest, and this is one more, can we agree that this number is too large to be stored inside of an integer? I think we can all agree to that. I'm going to say cout the value in too much is concatenated with too much. Take a second. Do you have any idea what you think would happen here? What's going to get displayed? Will memory just automatically resize itself and say, "Oh, you're just too much. I'll now make you a long int." Or you're too much. I'll just go ahead and make you 5 bytes instead of 4. Or I'll just give you one more bit. That should be fine. What is going to happen here? Let's give it a run. Negative 214,748,3648. Let's look back at our slides. That looks like the absolute smallest value we can hold in an integer. What that's telling me is that if you go over the max number, it doesn't know what to do except to cycle back down to the lowest. It's like a car odometer. Okay, your car odometer just read 99999. That's the only that's the most digits that you can have on your car odometer. You will cycle back down to 0. Okay? So, this is something that when we talk about trying to find errors in our program, trying to understand what's wrong with them, what's going on, if you are reaching a point where you've put too much into a variable type, that is a hard bug to find. Okay? So you got to be careful when you're using the variables that you are picking the right ones. Go ahead and comment this out. And let's look back at the slides. So looking back at the slides, we're just going to look at some of the stuff that they're doing here. One thing that you'll see is that you can define multiple variables inside of a program, and you can also define multiple variables on the same line. Matter of preference, so it just depends on what you want to do and what you're comfortable with. I personally never do this. The reason is because they have to be of the same type. So it's really honestly just personal preference, okay? Let's keep moving. Just looking at the integer literal numbers, just meaning that these are numbers that are already defined. These are the ones that we're using. And then that's just how to store different types of numbers. So if you're going to use a long or a long, you have to put an L at the end, just so that way it knows how to store it. But we really won't need any of that. We'll talk more about that, like I said, in CIS 268. Okay, so the next thing that I want to do is let's go over the homework, okay? So I'm going to X out of this, and I'm going to pull up your homework. This is homework 1. It's 50 points, distributed on the 7th, which will be the day that this lecture is released, and it will be due on the 20th at midnight. That is typical. You'll get it on a Monday at midnight, and it will be due in 2 weeks on a Sunday before midnight. It gives you 14 days to work on it. Excuse me. So, a couple things for the coding directions. Just make sure that you're labeling this in a specific way. So I need 2 different programs, program 1 and a program 2. So we'll say homework 1, program title. So homework, what I would do is homework 1, fewest bills. Homework 2, favorite city is what I will call those. Okay? You need to submit a Word file that states how to use the program and what the program does. This is a README file, and it must be submitted with all of your homework. Okay? You must have a README file with all of your homework. You should tell me what you've done, what you haven't done, what you weren't able to do. The reason that this helps is because I can start to correlate if there's something that I didn't cover well in the classes. I have 10 students who all said that they didn't know how to do X, Y, and Z. Sounds like I need to make a video on X, Y, and Z. I know it's scary to say, well, this is the thing I didn't do. It will be pretty clear what you did and didn't do when I run the program and look at your code. Okay? So just make it a little bit easier on me to correlate the data. That way I know when to make different videos. So I need 2 files, need to be zipped into a folder that is clearly labeled and uploaded on Brightspace. CIS 150, homework 02, your name. This is my name. I want that to be your name. John Doe. Whatever your name is, put it there. Okay, not my name. So what you'll do is I'm going to pull up this real fast, what my lectures look like. Okay, so let's say this. Let's say that this was my program 1 and this was my program 2. I hope you're with me. Program 1, program 2. I would come down here and I would make a new folder and I would say CIS 150 underscore homework 1 underscore, let's just say John Doe to get rid of the confusion. I would take these 2 programs and paste them into here. Do not zip these 2. Do not zip these two programs. Please do not zip these two programs. Okay? If you do that, then I have to unzip this, it is a pain. Okay? Once you have copied and pasted those two programs into here, right-click here, send to, compressed zip. Just saying it's empty. I say, but it should have made, if it did have something in it, a zip folder. Submit the zip folder on Brightspace. Okay? If you have questions about this, please let me know. But like I said, you take your two Visual Studios projects, put them into a new folder, zip them, and upload them. I do not want two zip folders. So I don't want this zipped, and then two submissions onto Brightspace. I don't want that. Okay? I want one folder with both projects and the README inside of it. If you have questions, let me know. Coding rules. Source code needs to be properly formatted. So I say that you can indent however you want. I stand by that. But having no indentation, no comments, that's not acceptable. Okay, so a comment header must be at the top. It has the name, date, and a program description. And then comments are used at your own discretion, but having no comments is not acceptable. You must have some kind of comment. Okay, even if it says, this is where I defined this variable. That's fine. Use them at your own discretion, but the people who fight the comments and say, this is my one comment, and that's your comment in there, those are the ones who have trouble on the final project where they don't even know, they can't figure out where they put something because they haven't learned the ability to write comments. They don't know where to put them and when to put them. Okay? If you have questions about the homework, post them to the discussion board first, and I will determine how to proceed from there. Go to the discussion board and post your questions there, please. Okay? If you see someone with the same question as you, hey, I don't know how to do this, or I don't know what to do from here. This is the error I'm getting. Reply to that person's discussion and say something like, me too. Okay? Remember, questions I put on the syllabus. There are appropriate questions and questions that I'm not going to answer. How do I do program 2 on the homework? I'm not answering that. I don't know where to start on program 2. Probably won't answer that either. Hey, I've tried these 3 things and I'm lost. Yes, I will help you there. But this whole class is about problem solving. You have to learn to break down a program, break down a problem, and start to code for that specific problem. Okay? So moving along, I'm just going to put this on a new page. Program 1 is the fewest number of bills. It's 15 points. This program will have the user input a dollar amount. You're going to say, well, we don't know how to have the user input stuff. I understand. I'm giving you 2 weeks so that you can maybe hard code this and make it work for a specific number just to see if your logic is right. And then when I upload the video for week 3 on how to get input, then we can combine those 2 things. Jump a little bit ahead, and that's fine. Look up the input if you want. Okay? If for some reason we don't get there, just trust that I'll extend the due date. Okay? This will be saved inside of an integer. This means that only whole numbers will be accepted. Once the dollar amount is entered, the program will figure out how to make the fewest amount with the fewest number of bills. Oh, the specified amount, sorry, with the fewest number of bills. The bills that will be used for this program are 20s, 10s, 5s, and 1s, and your output should look as follows. I have the user key into 15. I would listen at this point because I always have students who fail the assignment because they're not listening to what I'm saying here. I have the user put into 15. That does not mean that this program only works with $215. This program will work with any value as long as it can be stored in an integer. Once we get the values, I want this to be displayed. Then I want you to go through and cycle through the bills. You're going to say, well, I don't know how to do that. You never taught me how to do that. You never taught me how to get bills based off of a dollar amount. I guarantee you I will not teach you that. What I am going to teach you is how to do math. I will teach you how to get input. I will teach you how to do the output. As far as how you go about determining what the fewest number of bills are, given this amount, is up to you. That is the problem-solving aspect of this course. You need to get on board with that for this class. I know some of you are not software engineers, some of you are not computer scientists. For this class, you need to get on board with this. To fight me on it is going to be, it just will not work. You will not succeed in the class. I want us to succeed. This is about problem solving. How can I figure this out? This is no different. You could call this a change calculator. I go to the store. My bill is $25, and I give her a $50. How does the cashier determine what bills to give me back? That is what this is based off of. I show it running with 199 as well, and then I show it running with 7. That should tell you that this runs with any number. It's not just 215, 199, and 7. That is not how that works. Any deviation from this output will result in point deductions. Forgetting to put this here, point deduction. Not putting dollar signs here, point deduction. Not putting a spacer between these things, it would be a point deduction. You can call me a stickler, that's okay. But if you forget to do something, I have no way of justifying if you forgot to do it or don't know how to do it. So I have to go with the latter. Second program of this assignment is your favorite city character at a specified position. Very descriptive name here. This program will ask the user to insert their favorite city. This value will be stored inside of a string. Once this is stored, the program will ask the user to insert the position of the character that they would like to display. This program needs to work with any city that the user enters for multiple runs. So I show it working with Detroit. I show it working with Monroe and Woodhaven. This needs to work across any city that they enter. This program needs to work with any city. You cannot hard code in a specific city and let it to be displayed. The output should look as follows. Detroit, and I want to see the character at position 0. Notice that 0 is the D. 1 is the E. Okay, D is not at position 1. In computer science, we start counting at 0. So the user entered Detroit. The character at position 0 is D. There's a very specific reason why I'm asking you to do this. There is a function call that you need in order to get this to work. Why am I doing this and not telling you the function call? To help you understand how to use outside resources. Do a quick Google search. How to find a character at a specific position in C++. See what comes up. From there, you have to be able to read the documentation to understand. I am preparing you for future courses with me. Okay? I am preparing you for the courses to come if you are a computer science major. Okay, I had to pause for a minute. My son was calling for me, so I apologize if my thoughts don't kind of line up here in the video. But we were talking about making sure you can find that function call. It will prepare you for future classes. If by week 2 you still don't know what function call to use, let's have a discussion about it. Maybe I can put that in the video, but you gotta let me know in the homework questions, hey, I couldn't find anything. Maybe I'll post the website that tells you exactly what you can use. But by no means am I gonna just write the code for you and give it to you. Okay? And then it just goes on to say that any deviation of this output result in point deduction. And I say this program is designed to make sure that all students know how to look up C++ function calls. There's a function call that will return a specific character from a string. In addition, if a city has a space in the name, your code will most likely not work. This is okay. Okay, so if you put in some, like Ann Arbor, and it doesn't work, that's okay. Okay, so the point breakdown is as follows. Program 1, as long as it is successful, meaning as long as your output matches mine, and the logic is good, you'll get 15 points. Program 2, successful algorithm is 15 points. If you name your files right, you'll get 5 points. If you follow my coding rules, you'll get 5 points. If you attach the README file, you'll get 5 points. And if your output is formatted correctly across both programs, you will receive 5 points. What I see here is that you can get 15 points out of 50 without understanding how to code this. It blows my mind when students just turn in nothing. I don't understand that logic. You turn in nothing where if you just submitted something with the files named correctly, the zip folder named correctly, you followed my coding rules and tried something, and you attached a README that said, I don't know how to do this, I'll still give you 15 points. Submit something, please. Okay? If that's just going to be the end of this lecture. If you have any questions, please post them on the discussion board, and I'll be kind of cycling through that as the week goes on and trying to help you out as I need. Once again, if you see someone else's question, you know the answer, feel free to go ahead and hop on it and do that. If you see someone with the same question, like I said, just go on there and say, me too, or something along those lines. All right, I'll see you in the next video.